Hello, happy learner. How are you? Welcome, all of you, in my learning series, episode 3. I think jointly we just enjoy this journey. Today, I will discuss on event loop. It's a very hot question in interview. Every interviewer, if you giving interview on JavaScript, then it's a very essential to know about what is event loop. So in day-to-day basis, all we work on the asynchronous function, synchronous function. JavaScript is a synchronous by default, but we know we can able to make it asynchronous with help of async wait, promises, callback. Here, what is event loop? So I try to explain in details by showing one practical example as well. I just before go to in depth, I just share the diagram. Here you can see when a JavaScript code is executed, on that time by default it's a line executed one by one in synchronous way. So first of all, it's coming in the call stack, and the call stack immediately execute it, after that it's display in our maybe console or where we are displaying. So but we are not very much familiar with task queue and microtask queue. So definitely we know these things, but before that I just moved into the next slide. So you can see this is the diagram. Actually, what happened in call stack, actually, each and every line of code when we execute, it's executed by a call stack immediately. It's not waiting. When we use promise or set timeout or anything, but actually on that time it's coming in, it's just time taking any asynchronous task. It's coming under our task queue or microtask queue based on the priority. Microtask queue is the basic, very high priority. Is for fetching, that is coming here. Promise, that is coming under microtask queue. Yeah, and actually in browser, different API is that is not part of the call stack. When a JavaScript program is running, on that time fetch, set timeout, URL, local storage, session storage, age, all those things, it's a part of web API. That means it's a part of browser related things. Is what happened here, or when any fetch request is coming in on that time, and that is immediately, until unless we getting the result, and it is coming under the microtask queue, which is a high priority queue. And event loop, basically it is checking each and every time that is there any pending task, and any task waiting in the queue, and it is checking based on the priority. At first it is checking in the microtask queue, which is high priority. If is there any task available, then immediately it's proceed, sent to the call stack, and it is executed with help of event loop. If any task exists in the task queue, then it is also sent to the call stack, and it immediately it execute. So definitely, we will show by showing one example. Before that, at just in short, we know the definition. What is the event loop? So already I told you that JavaScript is single threaded, runs one task at a time. An event loop allow JavaScript to handle async tasks like fetching data, timers, without blocking the main thread. What is the key idea? Key idea is wait for task, execute them, then wait again. So this is the task of event loop. It's what event loop, all time wait for task. If any task coming, then execute them, then wait again. So the event loop actually basically continuously checking that any task is available or not. What I just shown you, the event loop actually is checking any queue. It may be under task queue or microtask queue. It is checking, is there any task is pending. If it is pending, then it is executed based on the priority. All time microtask queue get high priority. After that it will check task queue. So even loop continuously checking this. And how JavaScript execute code. So we already told that call stack, each and every each stack functions call in LIFO format, last in first out. Example, suppose there is a greet function here. We can see just in a simple greet function, we just console.log hello. Here, if we call the greet method, or so it's at first added to the stack. After that, run, then removed. So so you can see this is the call stack. So it's coming under call stack, execute and go out. This is the normal flow. And web API, what I told just few times before, or that means set timeout, fetch, DOM, any DOM event, all are web API. When called, they are moved out to the stack to run in the background. Actually, all those things run in the background. Set timeout, fetch, DOM event, and so in background mean it's coming all the web API. It's coming on the under task queue or microtask queue. And it's run in the background. And once completed, then even loop continuously checking is there any pending task is there or not. If there, then it is executed with help of call stack. So I think it's I able to clear these things. And callback queue or microtask queue, we just I am just define here, holds async callback as for example set timeout, dom event. So this is part of the callback queue. Oh, and microtask queue, what I told you, that's the higher priority. It's very high priority queue. It is actually then catch a finally, that means promise, or fetch operation. So it's coming under microtask queue. And even loop checks, what I told you, that even loop checks, at first is check, step one, is the call stack empty. If at first it's check the call stack is empty. If it is call stack not empty, then if call stack is empty, then it is checking in the microtask queue. Oh, if microtask, as because microtask queue, I told you that it's high priority. It's checking at first microtask queue. Under microtask queue, what is coming, fetch, then promises, all those are coming under microtask queue. And then it is check the callback queue, which is low priority queue. That means any set timeout, or this is coming. So even loop, this is the task of even loop, checking, is there any task exist under microtask queue or callback queue. Oh, here I am just giving one example in where even loop in action. So you can see there is 4 line of code, console.log start, set timeout, console.log timeout. Here I am giving 0. Promise resolve, then console.log promise, and after that console.log end. So what I told, that each and every time, and this console.log start, it is executed fast, not need to take help from microtask queue or even in callback queue. It's directly executed console.log, so it's printed immediately start. After that, set timeout, it's coming under callback queue, so it is waiting there, in callback queue. After that, promise also, it's coming under microtask queue, so it is also immediately from call stack move to the microtask queue. And it's coming the control under next pointer, that means console.log in. It's immediately executed by the call stack. So first start, then end, and after that, based on the priority, promise will at first send the response, and after that the set timeout. So this order will be we able to see. So definitely I will give you show you one example for that. And I just switch to, for better understanding purpose. See, this is the visualizer tool from where you can easily understand and what I want to show you. So, see here one method, log a, just simply I console.log. log b console dot log function log c, here also log c. In this way there is four method a b c d. After that what I did, I just call log a at first, then set timeout log b, then promise, then log d. So how it's execute actually? So if I just click the run, so you can see the step, you can see what I told, a each and every time when we run javascript code, it goes to the call stack and immediately call stack execute the code and return. But in case of set timeout or promise, on that case it is goes to the task queue or micro task queue based on the priority. So promise will go micro task queue and set timeout go task queue. So see the first line when I am execute this code, so it control come under log a. So what will happen, and it's moved to the call stack, you can see. So this way, at first run A, then D, then C. I think it will be better. I will explain it step by step. For that, I rerun the program again for better understanding purpose. So here I just run the code and I just stepwise execute it. First, when I execute this, that means line number 7 is executed. So you can see it's coming under log a, console.log a. It's coming to call stack for execution purpose, and immediately if the what happen, call stack execute this code. That means console.log a. So it print the a. So you can see it's print a. Next, what will happen? It go control goes to the number 8. So it is set timeout. So when I click on the next line, it is not coming under call stack. So it is moved to the uh, task queue. I told you that set timeout it is low priority, so it is go to the task queue. So it is not coming under call stack, and it is waiting for here. And next control goes to the line number 9. So you can see line promise dot resolve promise, that is it will goes to the micro task queue. Oh, so from here it is clear that log C still I am not getting any result. That means it will not print console log anything. It is all waiting in the queue. Oh, and our the what I want to say, that even loop continuously is checking these things. Definitely once this task will be done, before that the log d, that means it's simply console dot log. So it's coming call stack, under call stack and log d, you can see. And log d will console.log. So after a, d is printed in the console all, but b and c is waiting in the queue. Now event loop is checking, is there any task pending in the call stack? So there is no task available right now in the call stack. So what will the event loop actually, event loop continuously checking, he checking, is there any task available in call stack? No, there is no task available in the call stack. So this event loop is checking is there any task available in microtask queue, as because microtask queue is the high priority. So it is checking in that is there any task, even loop checking microtask queue, is there any task waiting in the microtask queue? Yes, log c is waiting. So it is immediately moved to the call stack. So you can see log c is now under call stack, and it will execute. So print log c, you can see log c is printed here. And after that, now again event loop is checking, is there any task available in call stack? So here you can see there is no task in call stack. So it is again checking event loop that is there any task available in microtask queue? No, there is no task available in microtask queue. So it's moved to the control task queue. Is there any task available in task queue? Yes, task queue, there is a task. So it is this task is moved to the call stack for immediately run. So it's coming to the call stack, you can see under call stack log b is coming. So now call stack execute this log b. So you can see execute this task as the and print console log b, and now it's released from the call stack. It will there is it's executed done, that means it moved to the call stack. So you can see event loop is one by one checking and complete all the tasks. And now again even loop checking, is there any task available in task queue or microtask queue? There is no task, so program is completely executed. So this is the simple example. I think from here I think it's very clear that what is call stack actually. Each javascript line by line, when we executed the code, it's run through call stack. A call stack, like a browser is not actually directly taking care of the browser API, right? Like page, any promise, or any async wait, or any set timeout, timer related things. That is not run by the call stack directly. Actually, immediately it goes to the task queue or microtask queue based on the priority. And once task is done, even loop is checking in which task is waiting, if is there no task available in call stack, and then one by one task is executed. So from there I think it's very clear. If you have any question, please let me know. And now I move to the next slide, that is just map, filter, reduce. It's commonly used JavaScript code. We in daily day-to-day basis, when we writing code in JavaScript, we using this a commonly used method. So basically, uh, it map use it when you want to transfer each element in an array and return a new array. We need to use actually in particular React. It is very useful tool, as because in React we iterate using map. It's return a new array. So on that time we use map. Definitely I will give one example. And filter, it is used for, or use it to create a new array containing only the elements that meet a specific condition. When some based on the some condition we have to filter, or on that time we used filter, and it is create a new array containing only the elements that meet a specific condition. And reduce, use it aggregating value or calculating a single value from an array like sums, average, or concatenated string. On that time we use reduce. Actually there is accumulator, and in accumulator what we want to hold, and another parameter is the in which field we doing the operation. So definitely we see this example one by one. And here is a common example, that means by using all those things in a filter, map, reduce in one single array, we apply this three method at a time. So definitely I will show you. So I now move to the coding part. So here you can see there is a employee array. It contains three attributes: first name, email, and age. So there is one, two, three, four, five, total five employee with their email and age. This is the a simple employee array. So if I need to just display all the name of the employee, then we just simply map. We don't need to want to display email and age, only want to display name. So just employees dot map employee dot email. In this way you can see on the right hand side, we display list of array element. It's creating new array element with containing only email. So in this time we use map and output of map. Okay, and after that you can see that uh, senior employee. So in time of filter, how many employees greater than 30, whose age greater than 30? So here I define one, and just constant variable, senior employee. So here it will filter all the employee whose age is greater than 30. In this case we just get all the array element. So you can see the entire array element it's written here 35 and 45, these two array element. And reduce, we use reduce for a sum of the suppose we want to calculate the total age of the employee. On that case we can use reduce. So accumulator and employee, there is two argument. In accumulator we hold the sum of the element actually. So we iterate and we hold the sum of the element in accumulator. Here it is the condition on, and just we the accumulator adding all the employees age here. So here I am getting total age by using reduce, and total number of employee we get employees dot length, and average age, that means total age by employees dot length. So you can see in this way I get total age is 160 and total number of employee 5. So 160 by 5 is equal to 32. So by reduce we can easily get the collective data as per our need. It so here and for the above example, we can and use this to in one method where suppose I want to get all the employee whose age greater than 25. I want their only first name, and we get as a comma separated value. So here I am using at a time filter map reduce. You can see I am employee is dot filter where employee age greater than 25, and map, in map method I just I want only first name, so employees dot first name, and reduce was I just concatenated all the result by comma. So this is the output. Combined uses example Alice, Bob, and David. I think from this example, these three things I think very clear. What we day to day basis when we coding on that time we use this commonly used map, filter, and reduce. Oh, so for today I think, and I will try in my next episode or to we jointly learn many more things. But for today, tata, bye bye. I just enjoy the learning and use in our day to day coding. Thank you so much. Bye bye.